Welcome to webinar dedicated to tornado. I'm Hervé Baour from Louis Bélet, and I'm happy to present you an innovation by Louis Bélet. And I have the privilege to have Rick Falgiatano from the US. He's a VP of Sales for Star SU, our exclusive partner in the North America.
Thank you, Hervé. And hello, everyone, and welcome to the webinar. Over the next 15 minutes, we will cover the various tornado tools and innovation used, as well as the technical points. At the end of the presentation, we will open the discussion for questions. Let's get started. Hervé, Louis Bélet created Tornado. Can you tell us in a few words what Tornado is?
Absolutely. So Tornado is nothing more than a range of high-performance internal lubrication tools. This range includes, among other things, tools for milling, drilling, and graving. And in the near future, we also will have all the catalog with the coolant-free capabilities, and so have an internal lubrication variant.
What we can say is that Tornado innovation is dedicated to medical, watchmaking, micromechanics, or any other market that requires extreme performance. Hervé, how does Tornado revolutionize machining?
Yeah, firstly by improving the productivity through enhancing cutting conditions. Then, thanks to an increased lifespan compared to standard tools and competition tools. And the overall improvement in the quality of machine parts, especially on the lifespan, the reducing of the burrs, and the surface finish. Finally, all these improvements make the machinery process very stable.
The first tool we're going to present today is the reference 336H, which is our pilot drill. Hervé, I'll let you introduce this drill and its role in the drilling process.
Yeah, this drill is a two-flute helical drill designed for pilot drilling for the reference 376H that we will see later on. It has a tolerance of +2 to +4 microns, which means it's a few microns larger than the long drill that will follow in the process. In other words, the pilot drill acts as a guide for the long drill that follows. This drill is capable of drilling without pre-drilling in solid material. There is no need for a centering tool.
I see a step on this drill, is that correct?
Yes, it's correct. So you have a 90-degree chamfer on the top of it. So this drill is dedicated to drilling stainless steel. So it was a complete development for drilling stainless steel, such as 316L, 904L, and it also excels in various steels, as well as cobalt chrome or alloys like Finox, for instance. The standard dimension is has a range of 0.8 to 3 millimeter. And of course, most of the time, like with Louis Bélet, you have the possibility to have custom variants in order to change the angle of the step or the length of the cutting edge.
Let's move on to the long drill, reference 378H-10.
Yes, this is also a two-flute drills, helical drill. It is used right after the 336H. or after a centering tool, although the latter option is not really recommended. This tornado drill can drill without pre-drilling at very high speeds. We will discuss this further in a video that will illustrate that better. Just like the pilot drill, this drill will work with the same material, and its diameter range is also from 0.8 to 3 millimeter. As indicated, the -10 stands for 10 times D. And it's important to know that in the future, in the near future, we also will have the standard version of this drill with 6 times D, 12 times D, and also 15 times D.
Yeah, that's good. Now we will discuss the innovations brought to these tornado drills. Hervé, there have been several developments on different themes. Can you tell us more?
Yeah, there were a lot of development in our R&D team, and we can mention 3 points. And the first one is about the lubrication channel. So we have seen that round tools or one holes of these lubrication channels were not optimal in the throughput on the flow of the lubrication. So we really did develop the shape of the holes. And the main goal of this development was to achieve the maximum flow of lubricant, as well as maximum resistance of the bending for this tool. And in order to achieve this, we developed a specific geometry and the position of the holes based on the shape of the flutes as well. And to reach such developments, we utilize finite elements analysis. As you can see on the top right hand, the colored picture up on the slides that illustrate that. So it's a really high-tech tool that we used in order to really define the shape of this drill. Further, another really important point for these tornado drills lies in the cutting edge. So we have developed a process that allows us to control the radius of the cutting edge based on the diameter. This is one point, and the other point is that we really did a polish of the flutes in order for the coating to be really grip on the carbide. Finally, the very last important point for this development is the combination of the carbide and the coating. With the help of our material supplier, we develop a carbide that meets the needs for machining tough material. To ensure its proper functioning, the choice of the TZ coating, which stands for titanium and silicium. So we use this TZ coating in next generation high pins coating, and this choice of this coating was obvious. You can see on the screen that you can see the cross-sectional view of the 376H, and you can clearly distinguish the carbide on the bottom part, inner part, the edge prep, this light roundness of the cutting edge, and the coating that envelopes it. But I mean, this is a high magnification, so the radius is really, really fine, all under control.
Let us see these two drills in action. On the left, you will find the pilot drill, and on the right, the long drill.
Absolutely. Basically, we do recommend the cutting conditions. In this example, were the following. So the cutting speed was 80 millimeter per minute, which translates to 15,000 RPM for a diameter of 1.75 millimeter. The feed rate is set at 650 millimeter per minute. This means the tool material contact time is just a few tenths of a second for the pilot and about 1 second for the long drill. So the use is really fast. One very important thing you can observe on the screen is the excellent chip fragmentation. If you are familiar with machining stainless steels, yeah, you have the chip that is really long, and it's really difficult to manage the chip evacuation. With this type of tool, you can see here on the image, on a fixed image, the really small chip. So the fragmentation of the chip is really important and controlled by the cutting geometry combined with the flow of the lubrication. So the tornado drill will greatly assist you on this task.
Well, the tornado range Residual chips and oil clags, is that an issue?
Yeah, well, the choice for this, so basically before going into this, what is really important is the high pressure for this tool, because the oil is really important, so you need to have a really clean oil.
High pressure pumps.
Yeah, exactly, as well as high pressure important. So the crucial for optimal lubrication and cooling during the drilling process. So we recommend a high quality oil that ensures efficient heat dissipation and minimize the friction. So yeah, to answer your question about the residual chips and oil clog the drill, so we recommend a filtration level no more than 0.02 millimeter or 20 microns, basically.
Okay, I see.
I can also add that for optimal function of these two drill reference, the maximum runout allowable is something like 3 micron.
3 microns.
Yes, it's really key to have a really tight hold and clamping system, but really the runout is really key within 3 microns.
Okay. So this also includes end mills. The first is 1620H, the Expert stainless end mill.
Yes, absolutely.
What can you tell us about that?
Yeah, sure. So this tool is a 4 flutes drill. It's similar to what we do have with the non-coolant through version. So it's a 1620, but it's with the edge adding the coolant through, and it's specifically designed for stainless steel and cobalt chrome. The diameter is goes from range from 1 to 8 millimeter, and the useful cutting length is about 2 times D. And here as well, the coating choice was the TZ. And niche prep is also available depending on the material and the application you do have.
Sure.
The second end mill that you see here is the 1520H. It's like the unlike the 1620H that we see earlier. It has 3 flutes. And it's a versatile end mill. That means you can use that in various material. So it could be used for both roughing and finishing. And for instance, if you want to machine titanium will be used. So the tool will be used with a mark coating. It's a homemade coating that we did at Louis Bélet, dedicated for micro machining titanium. If you want to use that tool to machine composite, we would recommend a sun coating, which is a diamond coating, really thin but really hard coating. And this tool is available from 0.3 to 8 millimeter, and also this tool has a 2 times D cutting length.
Okay.
Yeah. Basically, the most important innovation can be summarized into 2 distinct parts. First, the channels. So we had the development focuses on these channels. As you can see, we try to be as close as possible to the cutting area. So depending on the diameter of your tool, you will have the circumference or the position of the coolant holes that are really close to the diameter, to the cutting diameter. So if you have a larger diameter, the hole will be placed differently, but it means that for the diameter, the cutting diameter from small to really large, the raw material is different. So we did the close development with our carbide provider in order to have that. The second development lies in the tool geometry. So internal lubrication allows for drastic increase in cutting conditions, provided that the geometry supports it. So the the clearance angle, the cutting angles, and other parameter has been completely reworked for being used in this tornado family. Regarding the usage recommendation for these two end mills, also here we have the oil, which is really important. So the pressure can be lower than for the drill due to the larger channel size. But pressure of 20 bars or 290 psi is sufficient. But I mean, for an optimal use, we will recommend 50 bars or 725 psi.
Okay.
Do not choose viscosity higher than 20, and the oil filtration should also be a maximum of 30 microns, 0.03 millimeter. So with as with the drill, the maximum allowable runout is set to 3 microns, regardless of the type of tool clamping.
Good. Okay, we can see the 1620 end mill with a diameter of 2 millimeter in action on 316 stainless steel plate. The depth of cut is 1.5 millimeter and the width is 0.5 millimeter. End mill rotates at 30,000 RPM and advances at 2,000 millimeters per minute.
Yeah, it goes fast.
It's fast.
So I'll let you conclude a little bit
yeah.
in few words.
Sure. Well, in conclusion, the 4 points on the screen are those greatly improved by innovation of Tornado, and that's exactly why Tornado tools are the ones you need for quality, lifespan, productivity, and stability.
All right, so this concludes the presentation. Thank you very much, Rick, for joining me tonight or today. Yeah, we'll open the question session if you agree.
Sure. If there's any questions,
let's see what. Yeah, actually. So let's see what our audience can ask us questions, basically. Okay, so let's start with one. So what is the service life of the drills in stainless steel? So it's always difficult to answer this kind of question, right?
Yeah, it's difficult from the standpoint of are you measuring linear inches or are you measuring pieces and time and cut?
Yeah.
Difficult answer for that because of the RPM capabilities of your machine and your coolant supply.
That is true. So the stiffness of the machine, the runout, there are many points to consider.
Hardness of the stainless steel materials.
Absolutely, yes. But in the test we did with our customer, basically, we were at between 30 to 40,000 holes. So with a tool, I don't remember exactly the dimension of the hole. The depth was not longer than 10 times D, obviously. Okay. But still, I mean, 30 to 40,000 holes with one drill is...
That's excellent tool life.
Yeah, exactly.
Absolutely.
Yeah.
Yes.
All right.
Any other questions, sir?
Yeah. When will the tools be available for purchase? So if I may...
Sure. Yes. Like to know.
Yeah. All right. So we are in the process of filling the stocks. So we have stocks. Maybe not all the diameters, but 0.8, if I'm not mistaken, diameter 1, and maybe 1.5 are in stock. And the grinding machine are running full strength now in order to fill out the drawers. So yeah, we'll be ready for orders.
That's a good starter range.
Yeah, absolutely.
Good. I'm glad to hear that.
Yeah. Why is the tip of the pilot drill at 137 degrees and it's different to the drill bit at 135? So we have people who read carefully about the presentation, right?
Right.
Yes. So basically, the difference is based because we want the drill that comes after the pilot drill to use the tip of the drill.
Sure.
So that's why it's slightly different. It's not a big difference, but we want the tip to really work first into the material.
And 137 degrees will allow for the long drill to provide better and faster penetration rates.
Absolutely. Absolutely. So that's the reason why. Good
137
question.
degrees is unique.
It's unique?
Yes.
Yeah, we are unique.
Yeah.
We like to be unique. But it was a really good question, actually.
Yes.
So, can the pilot drill be used alone as as a stepped drill, and if possible, to have several useful diameter on the same drill? So yes, so the pilot drill obviously can be used standalone.
We did discuss that.
Yeah, absolutely.
Yes.
The only limitation as a standard, I would say, is that you have 2.5 times D.
Limited depth of cut.
Yeah, this is the limit
Sure.
of depth cut. But if you want to have the chamfer, you just go some tenths of millimeter deeper, and you have the 90-degree angle or chamfer, basically.
Absolutely.
And once again, as always with Louis Bélet, you also can have a custom dimension or angle or cutting length. So we are open to discuss about different various options.
Sure.
Okay. Are the tools only going to be standards, or can specials be purchased with the same geometry? So I think I just answered the question.
You did. Yes.
So,
and
yeah, the custom is one of the strengths of Louis Bélet. So we definitely can also use the same geometry of the holes, the same geometry of the cutting edges. For custom. So should that be custom diameter? Should that be in inches, for instance? Or length of cut? And we definitely will do a custom.
I could also add to that would be up to the existing length to diameter ratio, with future length to diameter ratios being considered.
Yeah, absolutely. Yeah, that's right. That's completely right.
So yes, absolutely. Specials, custom solution product, yes.
Yep. Okay, so I think we come to an end. Thank you very much, Rick.
I believe so. So thank you.
Yeah. So basically,
Thank you for inviting me.
Yeah, of course. You're always welcome here. And don't hesitate to go on our website, louisbelet.ch or lbsa.ch, and follow us on our social medias like Instagram or LinkedIn. So I think that was a wrap-up.
It's a wrap.
It's a wrap.
Thank you very much.
Thank you very much
Yes.
for attending the show, and see you next for future webinars.